I've been playing around with the LatenSync node for a couple of days now, and everything was going smoothly until I ran into a pretty big hurdle. Handling multiple characters in one scene, all facing the camera. LatenSync automatically picks which character to lip sync, and that's where things can get tricky, especially if you're working on two-shot scenes or projects with multiple people. Up to this point, most examples I've seen involve a single character. That works fine for social media clips or talking head videos, but it's just not practical when you need to manage more than one person on screen. To tackle this, I've worked out a workflow that splits into three main groups. The first group is the LatenXV image to video group, which handles creating the video. The second group is the basic LatenSync group. And finally, the last group is where we focus on isolating characters. Before we start, please like and subscribe for more videos like this. It really helps me out a lot. Let's begin with the image to video group. This is where everything starts, and if you've watched my previous videos, you might remember we've covered LatenXV before. Today, I'll just do a quick walkthrough of how it works. The group is organized into 6 main sections, and each one has a specific role. The first is the image upload section. This is where you upload your image, and it's also where you'll add noise. Adding noise might sound counterintuitive, but it actually improves both the quality of the video and the smoothness of the motion. Next, there's the loaders section. This part includes the model loader and the clip loader. For this project, I'm using the Q8 quantized clip model. Right below that is the load VAE node for the LatenXV VAE. One extra step I've added here is a force set VAE device node. This forces the VAE to use my graphics card because for some reason it started getting confused after I updated ComfyUI. If you're running into similar issues, this step can help ensure everything runs smoothly. The third section is the STG group. This uses perturbed attention, which helps improve the quality of the final output. Think of it like fine-tuning the video to make it look as sharp and polished as possible. Next to that is the Florence section, which generates a descriptive prompt based on the image. However, for this workflow, I'm not using Florence to create the prompt, so I'll bypass this section entirely. Next, there's the conditioning and save section. This is where the magic of sampling and saving the output happens. The final section is the upscale and frame interpolation group. Its job is to upscale the video and smooth it out by adding more frames. This creates a more fluid and polished video. The reason we're using the LatenXV group here is simple. It's to create a video that we'll later use to test the LatenSync groups. For my test, I uploaded a 2-shot video of 2 soldiers. Before uploading, I made sure to resize the image to 768 by 512, and I also made sure that the resize and keep proportion is true. For the STG settings, I'll leave everything on the default. The only thing I'm adjusting is the CFG scale, which I'm setting to 5 and the length to 145. Since I'm not using Florence to generate a prompt, I'll make sure the prompt switch is set to 1, which allows me to use my own prompt. I'll then add my custom prompt in the own prompt node. In the conditioning and sampler section, I'm keeping most of the settings the same, except for the steps. I've noticed that using lower step counts tends to produce poor results, so I'm increasing the steps to 100. Finally, I'm leaving the upscale and interpolation group off for now. After setting everything up, I'll cue the process and see what we get. The output isn't bad, but it's pretty much what I expected for a scene like this. Single subjects tend to perform better in these scenarios. I also upscaled the image, but I didn't add interpolation. For now, 25 frames are enough to move forward. Next, let's look at the basic LatenSync group. This one's pretty straightforward. You start by uploading both a video and an audio file. The audio gets synced with the video, and the final output is generated through the combined video node. The only thing you need to check before running it is that the frames per second, or FPS, is set to 25. To test this out, I'll use the video I just created. I'll upload it along with an audio file and see what happens. The LatenSync tool automatically decides which character to sync the sound with.
Man, what I wouldn't do for a cup of hot, dirty black army coffee. Man, what I wouldn't do for a cup of hot, dirty black army coffee. Man, what I wouldn't do for a cup of hot, dirty black army coffee.
And in this case, it's splitting the audio between both soldiers in the scene. As you can imagine, this is a problem if you're working with 2 characters who have separate lines of dialogue. This is where the third group becomes essential. It lets you isolate characters and assign the audio to just one of them. This group has two sections: the isolate character and sound section and the composite video section. The isolate character and sound section includes a video upload group, a subject isolation group, and an add vocals group. The composite video section is made up of a video pass-through group and a video composite and save group. Let's go through each part step by step. To start, I'll upload the same video of the two soldiers and run the process. Once that's done, I'll explain everything in more detail. Seeing the final product makes it much easier to follow along with the explanation. Let's see what the results look like. In the video upload group, there are two video upload nodes. You'll need to upload the same video to both of these nodes. Next to them is the resize node. This step is crucial because it ensures both videos are the same resolution. If the resolutions don't match, the image composite node will throw an error and stop the process. There's also a frame cap node, which limits the frame count to a specific number. For example, the video I uploaded has 145 frames, so I'll enter 145 here. This keeps the frame count consistent throughout the workflow. It's especially important because the LatenSync node tends to add extra frames to the video. Just below the resize node, there's a preview image node. This one's pretty simple. It acts as a visual aid to show you each frame of the main video. It doesn't affect the process, but helps you keep track of what's happening. Let's move on to the subject isolation group. This section starts with an image batch to image list node. It takes all the batch images from your video and turns them into a list. This list can then be used by the segment RMBG node. Before I explain why that node is in the workflow, let me just say that putting this together was like using chicken wire to connect pieces that really don't belong in the same sequence. It was all about finding a workaround, and while there might be a simpler solution, every faster method I tried ended up failing. The segment node is there because it allows you to prompt for a specific subject and removes everything else from the video. For example, in my case, I prompted for a man with a green beret on his head. The settings I adjusted include changing the threshold to 0.4. I also set the SAM model to SAM-VIT-L and the Dino model to grounding Dino Swin-T. These models download automatically, so you don't really have to worry about them at all, at least if you've got fast internet. The background color was changed to green, which is important because the video combine node doesn't work with alpha channels. Next to the segment node is an image list to image batch node. This one converts the isolated images back into a batch format that the video combine node can understand. Here's what I normally do. I disable both the add vocals and composite video groups temporarily. Then I set the frame cap to 1 and then Q. This step generates just one image, which lets me test and refine the prompt I'm using with the RMBG node until the segmentation looks right. Once I'm happy with the result, I increase the frame cap to around 15 or 20 frames to see if the character is being consistently isolated across multiple frames. After confirming everything looks good, I set the frame cap back to match the number of frames in the video I uploaded. Then I enable the add vocals group and the composite video group to continue the process. The next step involves the add vocals group. The video is passed into this group through the select file name and load video path nodes. From there, the video is sent to the LatenSync nodes. I switched the video length mode to normal since this isn't a talking head style video. The audio file is loaded into the load audio node, and that audio gets synced with the video through the LatenSync node. This process updates the character's mouth movements and prepares everything to be combined in the next stage. The output is then sent to the composite video group. This group starts with another select file name and load video path node, with 2 image batch to image list nodes and 1 convert to mask node. The first image batch to image list node passes the original video through to the composite node. The second image batch to image list node takes the images from the load video node and turns them into a list for the composite node. Below that is a convert image to mask node, followed by an invert mask node, which creates the mask from the images. All these outputs are fed into the image composite node. This node removes the green background we added earlier and combines everything together. Finally, an image list to image batch node converts the combined images back into a batch format. This batch is then synced with the sound from the upload audio node to produce the final video. When you run everything, you'll see the character isolated, the Lipsync applied, and the video restored to its original state, just with the new changes added.
What I wouldn't do for a cup of hot, dirty black army coffee. What I wouldn't do for a cup of hot, dirty black army coffee. What I wouldn't do for a cup of hot, dirty black army coffee.
There might be some minor bleed from the green background, but it's usually not too noticeable. If you're working on a longer video with back and forth dialogue, you could take this new video, upload it again, change the character by adjusting the prompt, and repeat the process for the next segment. This approach isn't a perfect solution, it's more of an experiment. It's also a bit of a shout out to the developers of LatenSync. Hopefully, if they see this, they might consider adding some kind of face index or segmentation feature to their node in the future. Let me walk you through exactly what you need to do to get everything up and running. You need to start by updating ComfyUI. Open your manager, click on Update ComfyUI, and once it's finished, restart ComfyUI. The only models we need to manually download are for LTXV. The rest will automatically download when you run them for the first time. To get the LTXV models, check the link in the description below. You'll find two options, the base model and the quantized model. You can download either one or both, depending on what you need. Once you have them downloaded, place the base model into the Models, Diffusion Models folder. The quantized model needs to go into the Models, UNet folder. Keep in mind that the base model uses the Load Diffusion model node, while the quantized GGUF model works with the GGUF model loader. Next, click the link in the description to download the clip loader. Again, you'll have a choice between the base clip loader and the GGUF version. There's a likelihood that you have this models, since it's the same T5 models that Flux uses. Both models need to go into the Models clip folder. The base clip loader uses the standard clip loader, while the quantized version uses the GGUF clip loader. The last thing you need is the VAE model. Use the link in the description to download it and place it in the Models VAE folder. Once that's done, you're all set with the manual downloads for this part. The rest of the models will download automatically, but if your internet is slow or you prefer to do it manually, there's a link in the description to the GitHub page for the RMB G2 node. Scroll down to section 3, titled Manually Download the Models, and look for the RMBG 2.0, the Grounding Dino model, and the SAM models. For RMBG 2.0, click the link to the Hugging Face repository, download everything there, and place it in the Models RMBG 2.0 folder. Create the RMBG folder if it doesn't exist. For the Grounding Dino model, you can choose between the SwinT or SwinB version. I'm using SwinT, but make sure it's the .pth version. Once downloaded, place it in the Models Grounding Dino folder. Again, create the folder if it's not already there. Finally, for the SAM models, you can pick any one of the three available. I've downloaded all three, but I mostly use the VIT-L version. Whatever you choose, make sure it's the .pth model, not the .safetensors version. Save it in the Models SAM folder, creating the folder if needed. Once all the models are in the correct places, restart Comfy. Drag the workflow file into your workspace. If you see a message about missing nodes, open the manager, click Install Missing Nodes, select the nodes you need, and hit Install. The LatenSync character isolation workflow might feel a bit like a patchwork of nodes that weren't originally designed to work together, but they do get the job done. And that's one of the unique things about ComfyUI. It's like a blank canvas. You can connect tools in creative ways to build something entirely new. If you know a faster or more efficient way to set this up, let me know in the comments. I'd really love to hear your thoughts, especially if it could save some time. Thanks for watching. Don't forget to like and subscribe for more content, and I'll see you in the next video.